of change we were talking about before. So remember what rate of change is. How fast or slow something is changing and moving, right? Okay, so average rate of change is the rate of change over a period of time. And we'll give you a picture of what I'm talking about in a second. But instantaneous changes, take a look at the root word. Instant is at one instant of time. So think about average as being over a period of time, and instant is at 1 second, at one instant. Yeah, I'm gonna show you a picture of what I mean. All right, so here's my curve. And we're gonna demonstrate the difference between average rate of change and instantaneous rate of change right here on this curve, right? So average rate of change is over a period of time. So if I wanted the average rate of change, let's say from 0 to 8, from x equals 0 to 8, I wanted the average rate of change, I will find the slope between these 2 points. Yeah, the end and the beginning. So the average rate of change is the rate of change from the beginning to the end, no matter what happens in between. All I take is the last point and the first point and find the slope. Remember how to find the slope between 2 points? Yeah, that's how you find the slope between 2 points. So if I wanted the average rate of change over that time period, that's exactly how I would do it. Find the point at the end of the time period, the point at the beginning of the time period, and find the slope between those 2 points. Now that's different from instantaneous rate of change. Instantaneous, just by definition, is the rate of change at an instant. So what if I wanted the instantaneous rate of change at x equals 3? Well, first off, let's see what the graph is doing at x equals 3. So here we are at x equals 3, here we are on the graph. Is that good? What about those tangent lines we were talking about before? Yeah, let's draw a tangent line right there. Yeah, look at that tangent line is doing something quite different than that average rate of change line was, isn't it? So average rate of change is like a big picture. And instantaneous is when you want to know what that curve is doing right there at that one instant. Yeah, because that's going to change. What if I did the rate of change at instantaneous at x equals 4? Ooh, it looks like it's bottoming out, right? So if I were to draw a tangent line, it would look like this. At that instant, it's not going up or down. At that instant right there, it's at the bottom of the curve, is not going up or down anymore. Yeah, this is going to be huge later. Because what do you think the slope of that line is? Horizontal line, the slope is 0. So listen, we're going to talk about later how important the slope of these tangent lines are. But for right now, notice how the instantaneous rate of change is different than the average rate of change. Good. So, all right, the only problem with these instantaneous rates of change, we don't have any exact points. So for right now, we're going to just kind of estimate, like this is an estimate of horizontal, right? With the average rate of change, we can get exact points. That's going to be a problem. I wish we could get an exact slope of this tangent line. We can. Derivatives. Oh yeah. Guys, look, derivatives are huge. There's like a whole math. There's probably like 2 or 3 maths just based on derivatives. Differential calculus is based on this thing right here. The idea that you can give a value for the slope of that tangent line. Now we're going to talk about a lot in class about how important the slope of these curves are at any point, and being able to figure out the exact value, how much this curve is increasing or decreasing at any point. That's what derivatives do for us. They tell us the slope of the tangent line at any point. And this one right here, where the slope of the tangent line is 0, is huge. It's all optimization. That's all minimization. When you want to optimize profits and minimize losses, this is the math you do. Yeah. Oh, there's plenty more videos after this about that. But you know what? I'm going to be there for those too. Oh, yeah. Yo, thanks for coming back, man. Thanks for checking me out. I'll see you next time.